Welcome back, everyone. Today we're going to talk about circles and equations of circles and graphing circles. So the definition of a circle is we have a point, and from that point, every other point is the same distance away. We call that r, or the radius. And the point we're going to call h comma k. And this right here is our standard form of the equation of a circle, with a center at h comma k and radius is r. Now, please note r is squared here. So if we have the equation in this form, we're going to have to take the square root to get r. Also, notice it's minus h minus k, but it's positive h positive k. What that means is whatever is here, it's going to be the opposite sign here and vice versa. So we're going to write the standard and general form. By the way, general form, this is standard form. General form looks like this. So this is general form. So let's start with part A. We have a radius of 3 in hk. Now remember, we're going to take the opposite signs of these when we build our equation. So this is going to be x plus 2 squared plus y minus 3 squared equals r squared, which 3 squared is 9. So here's our standard form. And what we could do to get the general form is FOIL that out, and bring that 9 over. So let's see what we get. Six plus 9 equals 9. Now you can see these 9s go away. I'm going to subtract the 9. What we're left with is x squared plus y squared plus 4x minus 6y plus 4 equals 0. So here's our general form. And we're going to go, let's go and graph this. We'll finish this up and then we'll do part B. So we have a center at -2, +3. And from there, we're going to go a distance of 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. There is our circle. And you can just do the best you can with it. Part B is actually easier. So we have a center at 0 at the origin. That's nice. That means we have x squared plus y squared equals r squared. So that's going to be 4 over 9. So here's our standard form. Our general form looks almost the same. And we could multiply through by 9 if we wanted to, but this is fine. So now we're going to draw the tiniest circle that I've ever attempted to draw. We are centered at 0, 0, and we're only going 2/3 of the way out. Ooh, tiny circle. There we go. Find the center and radius of the circle. So what we're going to have to do first on this one is divide the 2 out. X minus 2 squared plus y plus 3 squared equals 4, which means our center, remember it's opposite signs, +2, -3. And the radius is going to be r equals, remember, it's the square root of that. So r equals 2. We did it. We are now going to go in the opposite direction. Here, we got standard form and then FOIL it out to get general form. Now we're going to be asked, what if we're given general form? How do we get it into standard form? And that process, we're going to have to use completing the square. Let's start with part A. What I'm going to do for part A is I'm going to gather my x terms together, gather my y terms together, and then move that 4 over. Now, if you recall, the way we come up with completing the square is -6/2. We cut it in half, and then we square it. And what we do with this one is we take, again, the 2, cut it in half, and square it. So we're going to end up with x minus 3 squared plus y plus 1 squared equals, so it's 5, 6. And then it says right the center of the radius, center is at, remember we changed the sign, +3, -1. Radius in this case is √6. Again, that's r squared, so r is just going to be the square root of 6. For part B, because I'm getting a little low on space here, I'm going to factor out a 3 for the x terms. And on the y terms. Next, I got to complete the square, but this is going to get funky. Take that 5 there, cut it in half, and square it. It's going to give me 25/4. So I have to actually add 25/4 plus 25/4. This last one's no big deal. This is, I'm going to take the 4. Yeah. I have made an executive decision. It is too cramped down here, so I'm going to use some blank paper. So I can stretch this out a little. All right, so let's start again for part B. So I'll start B here. Oh, wait. So I'm going to go ahead and factor out a 3. X squared plus 5x plus 3 times, and I'm going to pull 3 up there again, y squared plus 4y equals -4. And I was trying to save space, but I'm not going to even try to save space anymore. I'm going to go ahead and divide everything through by 3, by 3, by 3. And that's going to give us x squared plus 5x plus y squared plus 4y equals -4/3. All right. So now what I'm going to do is complete the square like I did before. And that's going to give me, I'll use purple there, 25/4 plus 25/4. And for this one, I'm going to go 4/2 squared. That's 2 squared, which is 4. So I'm going to add 4 there, add 4 there. All right, so continuing on, this is now x plus 5/2 squared plus y plus 2 squared equals, and I'm going to show you a fancy little trick. If you have a similar calculator to mine, you can do this. There's no fraction key with this particular type of calculator. However, I can do -4 divided by 3 equals plus 25 divided by 4 equals plus 4 equals. And now I have a secret button. If I go to math, I can convert it to a fraction. Isn't that cool? So this means that we have 107 over 12. And it turns out I do have enough space. So the center, let's go down like this. So the center is at the point, remember opposite signs, -5 over 2, comma, -2. The radius of the square root of 107 over 12. It's not pretty, but it's there. All right. Part 2, finding the equation of a circle given some information. All right, so we're going to start with part A. So we have a center at 2, -3. Remember, we're going to switch the signs on that. And it has the point 0, 4 in it. So let's start here. X minus 2 squared plus y plus 3 squared equals r squared, which we don't know yet. But all we have to do is find the distance between the center and any point on it, and we'll be able to get what r is. So r is going to be, in this case, the square root of change in x's. So it's going to be 2 squared plus change in y's. -3 minus 4 is -7 squared. 4 plus 49 is root 53. So our equation becomes x minus 2 squared plus y plus 3 squared equals that squared. So that's just 53. There it is. So part B, we have endpoints of a diameter. And just to be clear, when we have a circle, the diameter is going all the way through the center to the other side. So here's an endpoint of a diameter, which means once I get, from here, I can get what r is. But before that, we need to find the midpoint of this line segment. If you remember, that's the average of the x's, comma, average of the y's. So 6 minus 4 over 2, this is the midpoint. And then we have 10 minus 4 over 2, which gives us, that is 2 over 2, which is 1. That is 6 over 2, which is 3. So there's our center. I'm now going to find the distance from the center to either of the points. So again, this is h, this is k. So I'm going to find the distance from the center to this, say this point here. So let's do the distance is going to be the square root of change in x's, -4 minus 1 squared plus -4 minus 3 squared. That's -3, -5, pardon me. Where am I? Yeah. So -5, that's 25. And that's that's 7, so it's 49. And that is going to give us 74. 74, perfect. which gives us our equation. X, remember opposite signs, -1 squared plus y minus 3 squared equals r squared, so 74. There you have it. No problem. Example 5, find the intercepts. Okay, so remember x-intercept, y equals 0. The y-intercept, x equals 0. So let's start with the x-intercept. So when y equals 0, we have x minus 3 squared plus, so when y is 0, that's just 2 squared. That's just plus 4 equals 25. And subtract the 4 over, x minus 3 squared equals 21. X minus 3 equals plus or minus root 21, which means x equals 3 plus or minus root 21. We can write those as points. That'll be 3 plus root 21, comma 0. 3 minus root 21, comma 0. There's our x-intercepts. For y-intercepts, set x equal to 0. So when x equals 0, we get negative 3 squared, which is 9. Moving the 9 over, subtracting the 9, I get y plus 2 squared equals 16, which very nicely is a perfect square. So y plus 2 equals plus or minus 4. So let's see what we got going on here. Negative, so that's 2 and negative 6, it looks like. We can write these as points. 0, 2, and 0, negative 6. Not too hard. You could get the decimal approximation for those. That'll just depend on what you're going to be doing with it, of course. Last part, find the exact area of the shaded region. So all we're going to do is take the outer circle, find its area, and then subtract out the inner circle area. So area of the shaded is going to be the, and remember the area of a circle is pi r squared. And we have 2 different r's in this case, which is fine. So area of the shaded region is going to be pi times 8 squared minus pi times 6 squared. 64 pi minus 36 pi. And here in a second, so it's 64 minus 36. That gives us 28. We don't have any units on this. Now, I want to point out this says exact. So if you multiply 28 times an approximation of pi, it's no longer exact. It's being rounded off somewhere. So this is the exact area. Not too bad. And of course, if we had units, we would put square, feet, inches, miles, kilometers, whatever it is. Hope that helps.